Okay, good afternoon. Can listen me or not?
Yes.
Okay, today I want to complete the 6.1 for the chapter 6. Okay, they're about the application of the electrolysis in the industry. Okay, so before that, we learn about the factor. First one is the electrochemistry for the series. Okay, number 2 is about the concentrations. Number 3 is the electrode. Okay, so from here, we're going to see the application electrolysis in the electrolysis in the industry. Okay, so from here, I go to share the screen first. Okay, so 6.1 is analyzing of the electrolysis in the industry. We're going to see got how many parts the electrolysis we can separate. Okay, we can separate by 4 parts. Okay, we can using extraction of the metal. Okay, we can using electroplating. We can using the purification. We can using the electrocoagulation for the wastewater. Okay, so from here, this all thing is related with the metal, and the last one is for the wastewater. Okay, we go through by one extraction of the metal. Okay, so first one, let's see the extraction for the metal. Okay, metal that extract through the electrolysis. Okay, through the electrolysis from their molten ores or salt. So that means during this one process, they need to using the oil. Okay, PJ. Okay, PJ DIMA. Okay, another one they're using the salt to extract the metal. So from here, example of the metal we need to extract is example using the potassium, sodium, calcium, magnesium, and also the aluminium. These all process we're using for the extract for the metal. So from here, you can see the important, the metal extraction. Why we need to do the extractions? First one, we want to obtain the metal from making metal utensil. We want to make it become liquid. Okay, after that, we need to do another thing. So from here, they're using making for the utensil. Utensil means the cooking material or the kitchen using one. The one is a utensil. Okay, normally it's a metal. Okay, so this one is important for the metal extractions. Okay, so impact of the metal extraction industry to the environment. Okay, although they're using the burning, you can see the diagram, they got burning. Okay, burning sure got pollutions lah. So from here, first one, they can destroy of the habits because you want to build. You build the supply, the factory for the extraction. Number 2, you cause about the pollutions because you need to heating, burning. You causes about the greenhouse gases and also global warming because of the heavy machinery in the quarries to extract the metal. So this all is disadvantages if we're using the extractions. But the problem, the extraction we need to do because we need to produce some of the metal utensil. Okay, unless you can think about another method lah. So this is one of the electrolysis process. Okay, they're using for the extraction for the metal. So from here, we continue to the next part. Okay, electrolysis for the extractions. We're going to see. Okay, we need to follow the reactive series of the metal. Okay, not every part we're using the extractions. Some part we're using another one. Okay, this one is a reactive series. So hopefully you are remember the arrangement. Okay, most active is at the top. The lowest one is less reactive. So from here, how to memorize? Okay, so from here, this one is a memorizing to let you to remember. Okay, remember we got insert certain of the element in. One is a carbon. Carbon they put at the middle between the aluminium and also the zinc. So that means carbon is a borderline. So potassium until the aluminium they can using the extraction for the metal. Okay, but the carbon below they're using another method. Okay, so from here, after the lead, they got hydrogen some more. This one is one of the things they put at the middle line to let you to know the process should be differences. Okay, so from here, how to memorize? Okay, you got 2 methods let you to memorize, like depend for you how to memorize. Okay, this one is including the carbon and also hydrogen. Okay, you can memorize about the reactive is please stop calling me a careless zebra. Instead, trying the learning how copper safe go. Okay, So another one you can learn like this. Please send the Charlie monkeys, but this one is never including the carbon and hydrogen. So you need to know where's the location for the carbon and also hydrogen. Okay, calling Charlie monkey and also the zebra in the lid cages. Okay, secure, guarded. Okay, so which one depend for you? You want to memorize? You want to follow the last time also can. The pop song one. Okay, for the zombie one also can. So this one, you need to remember because you got reactive series. They got including the carbon and hydrogen. Later we want to see what's different. The carbon and hydrogen they put there for what? Okay, for the arrangement you need to know which one should be the first, which one should be the second. Okay, let's see the reactive series of the metal. Okay, you see the most reactive is the top 5 lah. The top 5 is the most reactive. There's a potassium, sodium, calcium, magnesium, and aluminium. These all we're using the electrolysis. The normal electrolysis what we learned before that. Okay, after that you can see between they got one of the carbon blocking. Okay, the carbon blocking. So this part from the zinc until the lead, they're extract by the carbon reduction. So they're using the carbon to be extract. Okay, so that means just now first one is using the electrolysis. Number 2, they must including the carbon. Okay, to do the electrolysis. Okay, and the last one, you see the lead and also the copper. Copper and mercury, they're just hitting direct in the A. Just hit the copper and mercury. And the last one, the silver and also the gold, that one is a natural one. So we no need to do any electrolysis. No need to extract anything. So from here, that one is a natural things. Okay, so remember the arrangement. First, top 5, they're just electrolysis. Just now I show you the diagram, the extraction for the metal. Okay, they're using the oil, using the salt. After that, they need to burning. Okay, after that, the zinc until the lead, they extract by using the carbon reductions, and the copper and mercury straightforward hitting in the A. And the last one, silver and gold should be the natural. They no need to do any electrolysis. Okay, so this one is arrangement for the reactive series. Remember the arrangement and also remember the electrolysis, what they do it. Example, just now the extraction for the metal. Okay, they're using the iron, they're using the coal, they're using the limestone, carbon dioxide. After that, they put in. Okay, every level, different temperature. So they will produce a different of the products. Okay, finally, it's a hot air lah. Hot air at the base. After that, they produce a molten iron. Okay, they produce a pure iron to come out. So this one is a process for the extraction for the metal. Okay, then we go back to the first finish extraction for the metal. You need to remember the reactive. Okay, number 2, we go to the purification. Okay, purification, you can see impure metal and also pure metal. We need to using 2 things. Impure metal, we put at the anode. Okay, pure metal, we put at the cathode. Okay, you can see this one they're using what? Electrolyte, they're using the copper. Okay, they're using the copper. So these 2 electrolyte must copper. They're same like the electrolyte. Electrode and electrolyte must be same material. Okay, then they can do the purifications. So this one is a pure one. The pure one is at the cathode negative charge. Okay, the impure one, they put at the anode. Anode is a positive charge. Okay, you see the process? Okay, during the electrolysis, anode, there's a metal will be dissolved into the electrolyte to form the ions. Okay, remember this one we learned before that about the electrode. Okay, if the same material, the anode sure got problem one. The anode got changes. Anode don't have any part to discharge. No discharge already. Then straightforward, the ion will be dissolved into the liquid. Okay, now the liquid is an electrode lah, electrolyte. So from here, this one ion, they will move to the cathode to be discharged and also deposit at the cathode as a pure metal. So that means later the ion copper, they will come down. They will dissolve into this liquid. Okay, after that, they will go to the cathode, then stick to the cathode. So we said it there's a deposited at the cathode. So finally, what happened for the cathode? The cathode pure copper becomes thicker because just now the ion ore will stick to the pure copper. So finally, they say changes in the mass. The mass of the anode will be decreases lah, because they already dissolved the ion into the solid, into the electrolyte. Then the masses of the cathode sure increase, so because just now the ion ore will stick to the pure copper. So finally, the pure copper will become thicker and thicker. Then this one impure copper, they'll become thinner. Okay, this one we call purifications. Okay, they make the pure copper become more thicker. Okay, this one called purification method. Okay, first one extraction, then purification. Remember, they must electrode and also electrolyte. There's the same material. After that, anode. Anode is an impure. Cathode is a pure. Finally, the anode, they will drop the ion, go to pure copper. Then the copper becomes thicker. Okay, then we call electroplating. Okay, electroplating, what's the function? Normally, it's a metal, gold, platinum, and also the silver are electroplated on the other metal. Example, your key. Your key, the color is a normal color. So you want to make it become gold color, then you're using electroplating lah. Okay, maybe your key already rusting. Then after that, you want to make your key become more look attractive. Then you're using electroplating. Okay, electroplating from where? From the other metal. For example, you want to gold, you want platinum, you want silver. Okay, we're using the electroplating. Okay, on the other metal to make the metal look more attractive. Okay, and also withstand the corrosions. Withstand corrosion means they can stay for longer lah. No need to rust so fast. So from here, we're going to see the connections. For the anode, metal uses to plate the other metal. So the anode, normally you're using the silver, you're using gold, you're using platinum. That means what you want the color, then you put there. Okay, so that means the metal uses to plate. You want this one metal, you want to plate to the key. So you put at the anode. So cathode is what? Cathode is the metal you want to plate. Example, key. Or you say, I have a spoon. The spoon I lost silver color already. So you want to plating silver color. So the cathode, you put the spoon. Okay. Then the anode, you put the plate, silver plate. Okay. Then after that, electrolyte. So the electrolyte solution that contain the same ion as the metal used to plate. Example, if you're using silver, so your electrolyte must have silver sulfate. Okay, so must related. If you copper, then the solid must the solutions must be have the copper. Okay, depend the anode using what material, then your electrolyte must be followed. Okay, then we go through the diagram. Okay, this one's one of the electroplating. So this bar, you see the anode is a red color. So this bar, they're using the copper. Okay, black color, this part is a cathode. Cathode is the thing you want to plating. So they want to plating the key. Okay, so they just put here. So this one liquid must have the copper solutions. So from here, we just start to see it. They just find out finally. Okay, after some time, you can find the copper or they stick to the key. Okay, or the iron they stick to the key. So this one we call electroplating. Okay, almost same like the process of the just now, the purification. Okay, but this one they're not pure and impure. They just want to plate something to the another metal to make the metal become more attractive. Okay, so example, your nail. Okay, the nail you use so many times already, then after that got rust. After that, you want to reduce all the rust, then you can using electroplating. Okay. Okay, and the last one is electrocoagulation for the wastewater. Okay, we see what is it. Okay, this one, there's a innovative for the technique. They want to treat the wastewater. So from here, the electrocoagulation, actually they apply two process. One process we call electrolysis. Okay, they're still running for electrolysis, means the ion is moving. Okay, another one is a coagulation. Okay, we're going to see part by part. You can see the labeling. Number one is at the aluminium part. Number two is at the cathode. This one is a cathode, is a carbon. Okay, number three is talking about the aluminium ion is how to move. Okay, number four is a flow floating in the hydrogen gas bubble. Then number five we're talking about the flow, where to go. Okay, first one, electrolysis. We start with electrolysis. Anode is a metal electrode such as aluminium ions. Okay, ions in the electrolyte to produce a positive charge. There's aluminium ions. So for the anode, they will produce positive ions. Okay, there's aluminium. For the cathode, sure you understand. Cathode, they produce the hydrogen ion with discharge to form the hydrogen gas. Okay, so remember, one part is the aluminium, so they produce aluminium ions. Okay, another part, hydrogen gas they will produce because there's a hydrogen ions discharge. Okay, so from here you can see this one liquid is what? Gas bubble. This one is an aluminium sheet. This one is a hydrogen carbon. This one is a carbon plate. Okay, after that, they don't care about the liquid. The liquid now is a wastewater. Okay, wastewater, you know, they got H2O lah, water. So from the cathode, they will ionize is a hydrogen. Okay, so the aluminium plate, sure, they will produce the aluminium ions. So from here, this starting for cathode and also anode, there's an electrolysis. Okay, then 3 until 5. You see what's the process? Okay, 3 until 5, the process coagulations. Okay, number 3, you focus for this part. Okay, the aluminium and also the hydrogen, they will mix together with hydroxide ions. Okay, because the hydrogen gas already released, then they got hydroxide ions. Aluminium ion just now, the Al3+, okay, aluminium, hydroxide ions, okay, from the carbon plate, okay, and pollutants in the wastewater, they will combine, okay, to produce a coagulation known as flow. They're just like one of the big part for the, just like the rubbish lah, the big join together. That means they stick all the waste thing, they will stick together. Okay, later they bring the waste water, they will go up. So that means all the things you don't want inside the water, they will bring together and out. Okay, we call it this one as a flow. Okay, now the flow, they trap in the hydrogen gas bubble, released from the cathode, are brought out to the water surface. So that means just now the aluminium and also hydroxide, then they stick all the wastewater, combine, become flow. Then this one flow, finally they will trap inside the hydrogen gas. So you see number 4. Okay, just now the combined thing, there's a flow. They got red color, green color, and also gray color. These all things they combine together inside the hydrogen gas bubble. After that, they bring to the water surface. Okay, bring to the water surface. So they say flow floating in hydrogen gas bubble. Okay, number 5. Number 5 is the last one. The remaining float, they will sink in the accumulated at the base. So the rest, they never come out inside the gas bubble. So finally, they will sink. Okay, they will sink at the bottom. So this one, we call it as a sedimented of the flow. So this one is a combination for the electrolysis and coagulation inside the wastewater. So that means anything they waste, they just combine together. Then after that, trap in the hydrogen gas bubble. After they leave upwards. So leave outward, then you can do the filter lah. But at the bottom one, there's the waste one. They will sink at the bottom. So that means this one just like the filter in your house. Okay, your house outside, you put one of the tank of the filter, is it? So they got different layer. So this one is a one of the thing how they do the filter. So normally the bottom they put what stone, then after that middle they put the sand or something like that. They go to filter the water. Okay, so this one's every week they'll call you to open the water, let the water to flow, is it? So when it just come out, you see the water is gray, brown color. Okay, first round, there's a brown color. That means they release all the wastewater come out first. Okay, because they're at the surface. Okay, sorry, not at the surface, at the bottom. At the bottom to release out first. Then later, different for the layer. Then finally, the water become clear. Okay, this one is coagulations. Okay, by using the electrolysis. Okay, so that one is the last part for the electrolysis, only for the 4 application. Okay, extractions, purification, then after that electroplating, and the last one is the coagulations. So from here, you can see the formative practice 6.1. Okay, this one you need to do, need to do inside your exercise book. Copy the question, then we discuss now. Later, you just write the answer. Okay, first one, you need to draw and label the structure of the electrolytic cell. So in your mind, you must thinking electrolytic cell inside got what? You must have the battery. Okay, after you must have the wire lah. Then the wire join electrode. Electrode you got anode, then you got cathode. Then after that, inside the beaker you got what? You got solution, is it? The solution we call it as a electrolyte. So this one is a whole structure of the electrolytic cell. So you need to draw like this, Okay, you want to put rheostat or ammeter is up to you. Important must have the battery. Okay, then you must have the 2 electrode, anode and also cathode, then electrolyte. So you can draw like this also can. Okay, this one is a diagram with label of the electrolytic cell. Okay, this one's a question number 1. Question number 2, you need to describe the movement of the ions to electrode during the electrolysis. So the positive ion must go to find cathode. Negative ion must go to find anode. Okay, so we go to describe. During the electrolysis, positive ion means cations. They will move to the cathode. Negative electrode. The negative ion, there's the anions. They will move to the anode. There's a positive electrode. Okay, you don't want so mix so many different names. You just say positive ions. Then move to the cathode. Then you straightforward. Negative ion, then move to the anode. That's all. Give 4 examples for the application. 4 examples just now I show you already. The first one is the extraction of the metal, purification of the metal. Number 3 is the electroplating for the metal. 3 also for the metal. And the last one is a wastewater treatment using the electrocoagulations. Okay, so this one is 6.1 now. What you need to do? Okay, so after 6.1, 3 questions you finish. So I want you to see the summative practice. Summative practice, you got 2 questions you need to complete it. Okay, what's the 2 questions? That's the number 1 and number 2. You can see. Okay, the first one. We're going to answer this question. Okay, figure 1, they show about apparatus. They set up to study about the electrolysis for an aqueous copper 2 sulfate. Okay, they're using copper 2 sulfate. Okay, you see this one, copper 2, this one also copper 2. But this one electrode is a carbon. Then this one electrode is a copper. So you see what's the difference? Okay, first question. State the meaning of electrolysis. Okay, electrolysis, the meaning is process decomposition. This one you can find from your textbook. Okay, electrolysis is a process of decomposition of the compounds in the molten or aqueous. So that means you want the ions start to move, you must in the molten and also you must in the aqueous state. Into the constituent element when the electric current flow through it. So what you need to mention, last one must have electric current. No electric current, the ion cannot produce into the electrolyte. Okay, and also your electrolyte mass is the liquid, solid is cannot. Okay, so we got molten or you get aqueous, also can conduct the ions to produce out. So these 2 combined, then we call it as a electrolysis. Okay, must have the current and also make sure there's a not solid. Okay, number 2, can you state all the ion present from the aqueous? There's a copper 2 sulfate solutions. Okay, can you see the word copper 2 sulfate? Later, what they produce? First, sure copper 2. Copper 2 ion sure produce, that one is a positive one. Okay, sulfate ion sure produce, that one is a negative one. Okay, two more. One is a hydrogen, another one is a hydroxide. Okay, they sure will produce one. Okay, now they ask you which one will produce, so we just mentioned copper 2 ions, hydrogen ions, sulfate ions, then hydroxide ions. So the copper 2 and hydrogen is a positive one. Okay, sulfate ion and also hydroxide is a negative part. So later they will move to the cathode and also anode. Okay, C. Can you name the ions discharged at the anode and also cathode? Just now anode we say copper 2, is it? Okay, sorry. Go to anode is a positive, so there's a sulfate ion and also hydroxide. Okay, go to the cathode, there's a copper 2 and also hydrogen. Okay, we go and see anode first. Okay, anode is a sulfate and also hydroxide. Okay, now you tell me hydrogen, hydroxide. Okay, hydrogen. Okay, wait. I go to show first. I go to see back. Okay, these two is a negative. This one negative, you go to the anode. Okay, go to the anode. Sulfate and also hydroxide. Okay, sulfate and hydroxide. Now you tell me which one should be discharged. Okay, we're using sulfate or using the hydroxide. Okay, so anybody about this one idea? Copper, this one is a copper, this one also is a copper. So we see the answer for the first round. Electrolytic cell P. Okay, for the carbon first. For the carbon, actually it's a no changes lah. Okay, we just follow. For the carbon at the anode, sure we go to choose hydroxide because hydroxide is the bottom. Electronegative is higher. Okay, then after that we show cathode. Cathode we got copper 2 and also hydrogen. So the hydrogen or copper 2. So from here we choose with the copper 2 because hydrogen is above, copper 2 is lower. So we choose the copper 2. Okay, for the Q, Q got a little bit different because the electrode and the electrolyte is the same material. So you see the electrolytic for the cell Q. At the anode, we got copper. Okay, we also got the sulfate. Okay, sulfate is a negative. We got copper, 2 also copper. This one's a copper. Then after that, the negative ions will go to the anode. Then positive ion will go to the cathode. So anode is a positive. They will absorb the negative ion. Now the negative ion, we got sulfate and also hydroxide. Same like this one. Okay, so what happened? Sulfate and hydroxide, which one will be discharged? Okay, for the anode, actually, no ion discharge. Remember, the copper ion, they will dissolve into the electrolyte. After that, they will deposit it to the copper. Okay, they will deposit it to the cathode one. Then the cathode one become thicker. Okay, then this one anode, the copper become thinner. That one is same electrolyte. Okay, just like the purification. Remember, Okay, for the cathode, just normal. For the cathode, they will absorb what? They will absorb the copper 2, then they will absorb the hydrogen. Okay, from here, there also is a copper 2 ion will be discharged. Okay, you make sure you differentiate the carbon and also copper, what happened. Okay, then you need to see the liquid is what. Now the electrolyte is a carbon, is a copper. So 2 also is a copper. That means you must be careful for the anode part. The anode part no more discharge. Okay, they will dissolve into the liquid. If for the carbon, okay, safe. Both charge, they also will, both electrode, they also will be discharged. Then they go to find the lowest one. Which one is the lowest for the positive and lowest for the negative? Then they will choose. Okay, so you can refer back what we learned for the first factor. Okay, then question 1 again. Name one example of the application for the electrolysis in the industry, which apply the electrolysis concept of the electrolytic for the cell Q. Okay, just now the cell Q, we're using what application? So the application is a purification. Okay, just now I told you the copper become thicker, the pure one, impure one become thinner. So this one they're using for the purifications. Okay, number two. Number two, you also need to do. Okay, this one is a apparatus set up to study the electrolysis across sodium nitrate solutions. Sodium, they're using nitrate solutions. Okay, so they got electrode P. Okay, they got electrode Q. Using the carbon electrode, both also is a carbon. Okay, now state all the cations present in the electrode. Cations means positive ions. Positive ion. So you see the diagram lah. Sodium nitrate. Sodium sure positive. Nitrate sure negative. Okay, after that they got hydrogen, then they got hydroxide. Okay, so from here we're going to see first one. Okay, sodium ion, there's a positive. They go to find cathode. Cathode is a cation. This one positive ion, we call it as a cations. Then they go to find cathode. So there's a sodium ions and also hydrogen. Okay, they go to find the cathode. So now they ask you, can you state the ions present in the electrode? So ion is the balik lah. So from here, sodium, another one is a nitrate. So nitrate ions. Okay, hydrogens must together with the hydroxide. So there's a nitrate ions and also hydroxide. So these two is a negative. Then sodium hydrogen is a positive. Okay, so from here you can see the terminal. Positive terminal, they join with the electrode P. Understood, electrode P is an anode. Negative, they join electrode Q. Electrode Q, understood, there's a cathode. Okay, so from here, there's B. Which one electrode acts as an anode? So understood lah, P must be anode lah. So from here, electrode P. Name the ion chosen to be discharged at the P. Just now P got what? P got hydroxide and also the, okay, we go to recall back. P got what? This one is a P one. Okay, anode is a positive, they will attract the negative one. Negative, we got hydroxide, we got nitrate. So which one will be chosen to discharge? Sure, it's a hydroxide because hydroxide is a bottom one. Okay, if I go to the cathode, which one you choose to discharge? Sure, it's a hydrogen because hydrogen is the bottom one. Okay, we go and check electrode, there's a carbon. Electrode is a carbon and electrolytes don't have any carbon, so there's no need to do the purifications. So they just do the normal process electrolysis. So from here, we go to answer the first one. P is a hydroxide we choose. Okay, Q is a hydrogen will be chosen. Okay, explain your answer in 2C2. 2C2 is about the cathode lah. There's a Q. Okay, they just one Q only for the cathode. Okay, now explain your answer in the C2 based on the selection of the ion to be discharged. Okay, why we choose about the hydrogen to be discharged? Okay, the answer is sodium ions and hydrogen move to the cathode. So the hydrogen ion will be selected to be discharged because there's a less electropositive. Okay, remember the arrangement. There's a less electropositive compared to the sodium. Sodium, I think, should be number 2. Okay, then the hydrogen is a bottom one. Okay, so from here we choose the hydrogen to be discharged. Okay, so we just finished for the chapter 6.1. We still got 6.2. So what you need to do, just now I told you already, you need to do is the 6.1. Okay, 6.1, 3 question. And also the summative practice, only question 1 and question 2. Okay, this all is from your textbook. Then I also discussed for you already. So hope you can do it inside your exercise book. Okay, last but not least, you need to key in your attendance lah in the Google form. Okay, Google Form, I think got or not? I already sent to you or not? Okay, you can check about your Telegram. Okay, yes, okay, so there's a code, code, please typing there the code. The code is a carbon, capital letter for carbon, CARBON, hashtag, then the number 88, double eight. Okay, you just write, yeah, carbon, hashtag 88, that one is the code. So you need to retype, retype in the Google form, don't enter the space, no spacing. Okay, straightforward typing, then settle. No need to type anything already. Then you do the question. Okay, so this one is today what I want to perform to you. Okay, so the next one is tomorrow lah. Tomorrow I will go through to the 6.2. Okay, 6.2. After that, they finish the chapter 6. Then we go to chapter 7. Okay.